Alright, well this is for section 8.7 on linear inequalities, and it's going to be on page 20 of your notebook. Before we start, make sure you have a colored pencil, and just pretend like this is a colored pencil, and a ruler, and a regular pencil. You're also going to need to print 2 full sheets of grids and cut them out. You can print them from my math lab in chapter 8. Extra practice, you're going to have to print 2 sheets so that you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 grids. So if you need to pause the video, go print these out, cut them out, tape them down. 2 on the bottom part of page 20, and then 3 on the back. That'll be an example page, and 3 on the front of the next page, which is another example page. So 3, 3, and 2 on the front. So you can pause the video, take care of that, get it all set up just like mine, and then you can continue playing the video. Alright, so graphing linear inequalities. Just a couple things before we start. The first thing you always want to do for these is solve for y. It's very important to get y by itself. And the same rules apply. If you divide by a negative, you switch the sign. And then you will graph the line using slope and intercept. 2 things we need to know about that. We draw a solid line if we have greater than or equal to or less than or equal to. We draw a dashed line if it just says greater than or just says less than. So we graph like we normally do, but when we go to fill it in, it's either a solid line that has a line underneath or a dashed line if it does not. And then the third step to this is to shade. You shade above the line for greater than. You shade below the line for less than. You can also use what we call a test point. Or you can use what we call a test point. I don't like the test point. I'll show you how to use the test point. I prefer to just use the rule. You shade above for greater than, below for less than. I'll show you the test point though at least once before we start. So we solve for y. We graph the line, either solid or dashed line. Then we shade either above or below. And we're going to use our colored pencil to shade. Again, you'll just have to pretend like this is a colored pencil. Alright, so let's see how this works. We have example 1. If we have x plus y is less than 3. Step 1 is to solve for y. We want to get y by itself. And we're going to do that by subtracting x from both sides. So we'll get y is less than negative x plus 3. We want this in slope-intercept form. So we have our y-intercept, and we have our slope. Let's start with the y-intercept. That is the point 0, 3. So I'm going to go to 0, 3 on my graph and put a point. My slope is negative 1, and we're going to put that over positive 1, just like we learned. That means we're going to go down and to the right. So from my point, I'm going to go down 1 to the right 1, and I'm going to do that a couple more times. Down 1 to the right, down 1 to the right, down 1 to the right. After I have a few good points, I'm going to look at my sign. This sign says less than. No line underneath, so we're going to make a dashed line when we go to connect the dots. So you line your ruler up, and instead of making this solid line, we make kind of a broken dashed line along those points. It still has an arrow at the top and an arrow at the bottom because it does continue on forever, but it's a dashed line. So we've solved for y, we've graphed the line, now we need to shade. And I can just see this. Some students have a harder time seeing this. If you can ignore the axes, just pretend like the axes aren't there. Just look at that dashed line. And just think, if I had to choose between this side or this side, which side looks like it's less than the line? And in my mind, I can see that this side, all of this, again ignoring the axes, all of this is under that dashed line. It's not about the values on the axes, it's just about below the line or above the line. So you would shade everywhere below the line. So above is greater than, and below is less than. So if it says less than, we shade below. If you're not comfortable with that, some students have a hard time seeing that, you can grab what's called a test point. The easiest one to get is 0, 0. So I'm just going to take this value 0, 0. I'm going to plug in 0 for x and 0 for y into my original equation and see if it's true or false. If it's true, that's where I shade. If it's false, I shade the other side. So that's what the textbook talks about. You pick a test point. Generally, we pick 0, 0 because it's easy. Plug it in. If it's true, that's where you shade. If it's false, you shade the other side. So if I plug in 0 for x and 0 for y, that makes 0 plus 0 is less than 3, which is just 0. Is 0 less than 3? Yes, it is. So if this is true, that's the side I shade. I shade the side with 0, 0. If it's false, I would shade the other side. So that's the test point method. I don't really like it. I like to just look and see above or below, but it's up to you, whichever way makes more sense to you. Alright, let's do another one. Sample 2. We have 2x minus y is less than or equal to 6. So our first step is to solve for y. So I'm going to move this 2x to the other side. I have negative y is less than or equal to negative 2x plus 6. Then I have to divide everybody by negative 1. Each term has to divide by negative 1. That's going to change my sign. So now it's greater than or equal to positive 2x minus 6. It changes all the signs. So if y is greater than or equal to positive 2x minus 6. Now I'm going to graph this line. Again, we have our intercept. That's our starting point, 0, negative 6. And we have our slope, which is 2, and I'm going to put it over 1. That would be up and to the right. So I'm going to start at 0, negative 6. From that point, I'm going to go up 2 to the right 1, up 2 to the right 1. And I just keep going, up 2, right 1, up 2, right 1. Continue until you have a few solid points. Then when we go to connect those points, we look at the inequality. If it has a line underneath, we connect with a solid line. So we're going to connect this up with a solid line, arrow pointing down, arrow pointing up. Then we look at the actual inequality. Here we had to change it, so this is where we look. It says greater than. It says y is greater than or equal to 2x minus 6. So again, if you ignore the axes and just focus on the line, you look what side is above the line and what side is below the line. I tell my students, think about it like a seesaw. If the kids were on a seesaw, they would be on this side of the seesaw. So that's the top. If that makes sense to you, that's where you shade. So this time, this is above, and this is below. It depends on which way the line is tilted. Ignore the axes. It's just about above or below. So this time we're going to shade above. Just have to pretend like this is a colored pencil. And if you want to use a test point, you can. So if you don't like the above and below thing, you can use a test point. Like I say, I like to use 0, 0. I plug in 0 for x and 0 for y into the original equation. 0 is less than or equal to 6. Because this would be 0 minus 0. 0 is less than 6. That's true. If it's true, that's where you shade. And so you'll notice we shaded 0, 0. So test point or above and below, whichever makes sense to you. Alright, let's move on to another example. So on the back of that same page is an example page. We're going to do a few more of these. So example 3, we have y is greater than or equal to x plus 2. Good news, it's already solved for y, so we just can jump right into graphing. Here's my starting point, 0, 2. My slope is 1. I'm going to put it over 1, and that's up and to the right. So I start at 0, 2, and I go up 1, right 1 a few times. It has a line underneath, so I connect this with a solid line. And then above or below, this is a greater than. And again, ignore the axes, just focus on the line, which side is above the line and which side is below the line. If you had kids on a seesaw, they would be sitting on this side of it, and that would be the top. So we're going to shade above the line. So this is above, and this is below. If not, you can use 0, 0 as a test point. When we do that, if we plug in 0 for x and 0 for y, is 0 greater than or equal to 2? That is not true. So if we use a test point, I like 0, 0. If I plug in 0 for y and 0 for x, 0 is not greater than or equal to 2. That's not true. And you'll notice we didn't shade where 0, 0 was because it's not true. So test points work. It's a little more effort. But if you're not sure, then you would use a test point. All right, we'll keep working here. Moving right along. Example 4. We have y is greater than negative x minus 3. I'm going to let you try this one. It's already in y equals form, so just get it graphed. Solid or dotted line, above or below for shading. I'm going to let you try that one. Pause the video and try it, and then you can push play again. Here we have the y-intercept. That's at 0, negative 3. Our slope this time is negative 1, and we're going to put that over positive 1. So remember, only one of them is going to be negative. The other one stays positive. That would be down and to the right. So 0, negative 3 is where we start. Down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Just keep going until you're tired of it. And then connect with a dashed line because there is no line underneath this. So we'll connect the dots with a dashed or broken line. Arrows still at the top and the bottom. And this says greater than. Greater than. So we shade above. And again, it's just a visual thing. If you ignore the axes, this side is above and this side is below. So this time we have above over here and below over here. And we're going to shade above for greater than. So we'll shade the top half above the diagonal line. And if you're not sure, again, you can use that test point of 0, 0, and it should be a true statement. All right, example 5. Oops. Example 5. Let's do 2x plus 5y is greater than or equal to 10. This is going to take some work to get it into y equals form. So we're going to have to move that 2x to the other side. That gives us 5y is greater than or equal to negative 2x plus 10. We need to divide everybody by 5. And each term has to divide separately. So we're going to have y is greater than or equal to negative 2/5 x plus 10 divided by 5 is 2. So here's our starting point at 0, 2. My slope is negative 2 over 5. Remember, only the 2 is going to be negative. Leave the 5 as a positive. So that's going to be down and to the right. So I start at 0, 2 on my grid. I'm going to go down 2 from there and to the right 5 and put another point, down 2 to the right 5. And I'm out of room. You can also reverse that and go up 2 and to the left 5. Up 2 to the left 5. So you can reverse that and still make your line. This time we're going to have a solid line because there's a line underneath the inequality. So line up your points. We have a solid line. Arrows. And this is greater than. So you have to wait until it's in y equals form. Once it's in y equals form, that's the inequality you use. It's greater than. And again, we just look above and below this line. So this is above and this is below. This says greater than, so we're going to shade above that line. If it said less than, we would shade below that line. Alright, let's try a few more. 3 more of these. If I'm going too fast, remember you can pause the video and watch it again, or pause it and try on your own, and then push play, and then you can see how I worked it out. So feel free to pause and go back and watch again, or pause it so you can see what I'm doing. Whatever you need to do. This video is very flexible. Alright, example 6. We have x plus 2y is less than negative 2. If you want to pause and try, you're more than welcome to. We're trying to solve for y, so we're going to move the x over. That's 2y is less than, I'm going to put the negative x first and then minus 2. Then everybody has to divide by 2. There's a 1 here. I really like to put the 1 when I've got a fraction. So put that 1 in front of the x. Those 2's cancel. I have y is less than negative 1/2 x minus 2 over 2 is 1. So your y equals equation, or your isolated y equation, y is less than negative 1/2 x minus 1. From there, we should be getting good at this. Here's our y-intercept. Here's our slope. Remember, our slope, only the top number is negative, so it's going to be down and to the right. So I start at 0, negative 1. I go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. You can reverse that and go up 1 to the left 2, up 1 to the left 2, as long as it stays on that same line. Alright, from there we're going to connect it with a dashed line because it does not have a line underneath. Turn that brightness down. Alright, so dashed line, line up the points. Dashed line, arrows. And then we've got above or below. This is a less than sign, which means below. And below that line is under it, or above. Above would be for greater than, below is for less than, so that's where we are. We shade below that line. And if you use the test point 0, 0, it should not be true. So you can always plug in 0, 0 and test it, and that should not be true because we did not shade there. Alright, 2 more. These are always the confusing ones. So example 7 is just y is less than or equal to 5. Now remember, this is an equation. It does make a line. Y is less than or equal to 5. We're going to graph it as if it says y equals 5. So we're going to go to y equals 5, and we're going to go to the right and to the left. It just keeps equaling 5. Wherever the x value is, y equals 5, and it creates a horizontal line. We're going to do solid line because of the line underneath it. And this is less than, which means you shade below. And this one's a little easier to see. This is below, this is above. Above the line, below the line. Because it's less than, we shade below. So anything below that line is true. So if I use the test point 0, 0, it should be true. 0 is less than 5. So that's a true test point. Alright, and the last one. X is greater than negative 3. So we're going to graph this just like it's a line, or just like it says equals. You're going to find negative 3 on the x-axis and go up and down, staying at negative 3 on the x-axis. That creates a vertical line. We're going to use dashed because it does not have a line underneath. So dashed line vertically up and down. Arrow up and down. It continues. So we have a dashed line. Now this is a little different. Above is to the right and below is to the left. Which again makes sense to me. Above is the positives, below is the negatives. That makes sense. If you're not sure, you can use that test point 0, 0. 0 is greater than negative 3. That's a true statement. So this is greater than. Or you can use your test point. That side is true, so that's the side you shade. Anything to the right of that line. So this is relatively straightforward. It's not really anything new other than the shading and the solid or dashed lines. You just have to be good at your graphing, and then you think above or below, or you use a test point, which generally we use 0, 0. So that is how to graph inequalities, linear inequalities. You solve for y, you get it on the graph, solid or dashed line, and then you shade.